Okay. Hi, I'm Terry Zitrich from the Vermont Astronomical Society, and I'm here to show you how to use this telescope that your library has so generously provided you to check out just like a book. So this telescope is a small 4.5 inch Newtonian telescope. And a Newtonian telescope is different from a Galilean telescope, and that's the typical telescope you see with the lens at the front, eyepiece at the back, and that the light comes into the front of this telescope, like most telescopes, but the eyepiece is also up near the front. So this is where the eyepiece is. And so you're going to look into, when you take this cap off here, you're going to look into this place on the telescope. So again, it's a 4.5 inch telescope. It's got about a 450 millimeter focal length. That's the focal length of the telescope itself, and that helps define the magnification and uh, what you'll see in the telescope in the field of view. So, what you need to know about the telescope is it's a tabletop telescope, so this is something that you don't want to use on the ground, obviously, unless you want to lay on the ground to look through the eyepiece. So you'll put this on a picnic table or some table in your backyard, and it moves in azimuth here. It spins all the way around in azimuth. You can't hurt it. You can spin it around as much as you want to point to your object, and it moves in altitude this way. So, and again, you look through here and you focus here. So something about this eyepiece, this is actually a zoom eyepiece. So when you're looking for something initially, what you want to do is if you look here on the edge of the eyepiece, maybe you can see it better here, you have um, different definitions, 24 millimeters, 18, 12, and 8. So 24 millimeters is going to be the lowest magnification. So when you're looking for something, start off there at 24 millimeters. And then once you get it, you can turn it to higher magnifications all the way to 8 millimeters. And that will give you the highest magnification the scope can provide with this eyepiece. You'll probably need to refocus it a little bit as you change the focal length. But that is the way you'll get a different field of view and a different magnification. And the magnification of all telescopes is equivalent to the focal length. So I said this was 450 millimeters divided by the focal length of the eyepiece. So it's either that 450 divided by 24 millimeters at its lowest power or 8 millimeters at its highest power. And we've got a little magnification chart on the side telling you what those magnifications are at the different eyepiece zoom level. So at 24, the power is 18. And at 8 millimeters, it goes all the way to 56. So you'll be able to see tons of objects with this telescope in those ranges of power. You'll be able to get beautiful views of the moon. This is a really great lunar telescope. And in the pocket here in the front, if you can see this, I guess you can't see it here. This pocket right here in the front will have a small lunar map showing you some areas of the moon to look at, as well as you'll have a constellation guide in the pocket here. You can also see things like you can certainly see the moons of Jupiter and Saturn. You could actually see really well the rings of Saturn. You can see some of the bands of Jupiter with this telescope. It's actually quite a good little telescope. One of the things that you'll have to learn how to use, because finding things with a telescope is hard if you just look through the eyepiece and try pointing it. It's much harder than it looks unless you're looking at something like the moon. Then it's a little bit easier, but it's amazingly hard even to find the moon sometimes, especially if you have the magnification turned up again. So again, keep your magnification low at the setting of 24 millimeters, and that'll give you a pretty low magnification, make it easier to find things. But if you're looking for things other than the moon, like Saturn, you're going to want to use the finder. So that's this little thing here. It's called a red dot finder, so it has no magnification. So when you turn it on, you look through the back here, you look through this tube here from the back, and what it does is it will project a little red dot on the sky. So it's called a zero power because it has no magnification power. So you just look through it, you point the telescope up, and you put that red dot where you want to observe. So if you see, again, Jupiter and Saturn are usually pretty bright in the sky. You come from the back like this and you look through that and you'll see a red dot, and it will basically look like that red dot is projected right on the sky. So you put that over the top of Saturn or Jupiter or Andromeda, a galaxy that you would be able to see in this telescope as well. Um, you place it on, or the Pleiades, you place it on the object. Then you come over and look through the eyepiece, and it might not be perfectly centered. Again, start at the lowest magnification, which is the largest focal length of 24 millimeters in the eyepiece. Look through the eyepiece for a bit, um, get it centered, focus it, and then you can crank up the magnification based on the seeing. So on better nights, you can have higher magnification. And when I say better nights and seeing, I'm talking about the atmosphere. So sometimes the atmosphere is really wobbly and looks like there's heat waves going through the atmosphere. Um, that's exactly what that is, little cells of air that are moving up and down through the atmosphere. When there's a lot of those, you want to keep the magnification lower, and that'll give you a more pleasing view. You can turn up the magnification anytime you want, but on those nights of bad seeing where there's a lot of thermal cells in the air, everything looks like it's boiling through the eyepiece. So sometimes that's not as pleasing. But again, you can always turn it up. It's up to you. Um, there's a few things here. We have places, we have Velcro on most of these things to place them so that they don't get lost. So the Velcro on the cap has a little place in the base where you can set it. Your eyepiece cap has Velcro where you can place it right on the top of the tube behind the beside the eyepiece. Make sure when you're done to turn off the red dot finder. This is the switch you want to use here on the side. This is a battery box. So just turn it, slide it up, that turns it off. Um, there's nothing you really need to adjust other than the focus and setting the eyepiece focal length, which is just a twist. So fully clockwise, you're at the lowest magnification. Fully counterclockwise, you're at the highest magnification. So again, start at lowest. Nothing at the back to touch or adjust. These buttons adjust the optical alignment of the telescope, so you don't want to touch anything in the back. This sets the how easy this is to turn or how well it stays up. So I'd keep it stiff enough so it doesn't fall, but easy enough to move slightly. So set it to the way you like it. Just don't leave it completely loose because then you really won't be able to look at anything for any length of time. So things will move. This isn't a tracking telescope. Things are going to be moving when you look at them, so you'll have to adjust. So that's why it's best to have this just so it stays up, but is also really easy to move in very small increments without it being jerky. So some other things that are included here, we have a planisphere. So this is something that you can look up on the internet, but on how to use, but I can show you real quick here. So you hold this, and when you're facing south, you can look here, and this will give you an idea of what stars are up different times of the night. So it has a scale along the edge in months and days, and then a time. So if you set, for instance, say we were going to observe tonight at 9 p.m. So this is September 12th. So we're going to look for September on the ring. So September is way over here. And then we're going to line up 8 p.m. with September 12th. Or 9 p.m. with September 12th. So that's about here between 11 and 13. So if we hold this south, what we're going to see is right in the middle of the sky, right up above, is something called the summer triangle. So it's the stars Altair, Vega, and Deneb. So if you hold this up and you hold this up to the sky, that's the location of those stars. So that you get a really nice star map over here farther to the west as they're setting. You're going to see a very bright star called Arcturus, actually the brightest star in the sky right now. And coming up, if you were up later, you might even see something called Capella. So if you were up, say, till midnight. Say if you were up till midnight facing south, Capella will be rising in the east. That's another very bright star. So that's how you use a planet sphere. This is facing south, but you can also do it facing north in the same way. So you line up the month and the time that you're observing, you put this up into the sky, and this is basically, you can look at what stars are up. You can also use a smartphone. Of course, everybody has a smartphone, and or most people have a smartphone, or your parents do, and you can have a star atlas in your smartphone. That's another app you can put up, and most of them have compass capability, an accelerometer capability, so that you can hold it up to the sky and you can see what's up uh, for things to observe. Um, there's also in here, so if you want to look at, and you can't see this because it's too dark out, it's best, of course, to be in a really dark location. And that's what we have this for. This is uh, a red light and white light headlamp. So put it on your head. And what you want to do is you want to use the right side light, which is red. So when you want to do things associated with observing, when you're done for the night, of course, you can turn on the white light as long as there's nobody else observing around you to see where you're going and get back to into your house or put things away. But while you're observing, you really want to use the red light because the red light will prevent your eyes or keep your eyes dark adapted while you're outside observing. Because the longer you stay outside without white light, the dimmer the star that you'll be able to see, up to about magnitude 6, or even maybe even dimmer if you're young. So I can't see anything over 6 right now myself. So you just have to hit the right button a couple of times to turn it both to the setting you want and then off. So again, use the red light. Use the red light to look at the constellation guides or the planisphere, or also included in the pockets on the front of the telescope here is a guide on how to use the telescope. So most of the things I've told you are included, including how to use the eyepiece, how to use the finder, never look at the sun. So that's something that we have a sticker on here. Never look at the sun with this telescope, or really never stare at the sun with unaided, without some kind of solar device. So this telescope is not made for solar. You will damage your eyes by looking at the sun or pointing it anywhere near the sun, so keep it away from the sun. This is mostly a nighttime telescope. Of course, you can use it during the day to point towards distant buildings or birds or trees, but don't point it towards the sun. You could damage your eyes very bad. This is like having a 4.5-inch wide eyeball plus some magnification, magnifying that solar energy into a very small spot on your eye. So it would damage them severely. So don't do that. No looking at the sun. And I think that is just about it. There will be information included with the telescope when you sign it out, such that if you need help, you can call somebody or contact us at the Astronomical Society or somebody at the library to help you. And with that, feel free to reach out to the Astronomical Society if you'd like to get into astronomy more. We're at vtastro.org, or if you want to send us an email, we're at info@vtastro.org. And we welcome everybody to the Astronomical Society. And that is all I have.